Hello and very warm welcome. Assalamu alaikum. Good afternoon. I think I'm audible.
We can hear loud and clear.
Yeah, thank you so much, sir. I think we should start. Assalamu alaikum, everyone. Good afternoon and very warm welcome to all the participants and our guest speakers for today's session. I'm Asif Rashid and I'm going to moderate today's session, which is about composite materials bringing about revolution in aerospace and automotive industry, which is being organized by Pakistan Aerospace Council. Pakistan Aerospace Council is a not-for-profit organization for enterprises active in aerospace, defense, high-tech mechanical, and electronics market. Pakistan Aerospace Council is working for global promotion of high-value addition and technology manufacturers of Pakistan, while meeting the needs of technology acquisition as well as export-led sustainable growth of Pakistani aerospace and high-tech industry. Without any delay, let me introduce the guest speakers for today's session. Our main panelist for today's session is Dr. Yasir Nawab. Dr. Yasir Nawab is a PhD in mechanical engineering with focus on composite materials from University de Nantes, France, and have experience of working with renowned European industrial groups dealing with composite materials and AUNERA, the French Aerospace Lab. He worked as a chairperson DICE Textile, Pakistan from 2015 to 2019. He is the founding director of National Center for Composite Materials, National Textile University, a fellow of Textile Institute UK, the member of Government of Pakistan's sub-working group on CPAC textiles, as well as a member of several national and international bodies. He has been awarded with HEC's Best University Teacher Award 2017 and DICE Leadership Award 2018. He is Dean, Faculty of Engineering and Technology, National Textile University, Faisalabad, and he is doing research on 2D and 3D, textile fabrics, finite element analysis, and composite materials. Apart from this, we have with us very renowned Dr. Arshad Ali. Dr. Arshad Ali is the recipient of Stara Imtiaz and Pride of Performance from Government of Pakistan. He completed his PhD from United States of America, and he served as Executive Director of Higher Education Commission, HEC, Vice Chancellor of National Textile University, Faisalabad, Dean, Nurse Islamabad, as well as Pakistan Air Force. So we will start this session. Dr. Yasir Nawab, over to you, sir.
आपका माइक ऑफ है यासर.
Bismillahirrahmanirrahim. Thank you very much, Asif. Thank you very much, Dr. Arshad Ali Sahab and Dr. Imtiaz Rastgar Sahab for giving me this opportunity. So to start with, I will play a small video to share with you about composites, and then we will continue with my presentation.
I'm a composite material. Do you remember me? I'm certain we've already met. I'm strong, resilient, and light. You've surely seen me around a lot, in one form or another. I also have a secret that's as old as time itself. My secret is fiber, carbon, or glass, hemp, or linen, and many other kinds. Bound by a matrix, my composite material offers qualities that far surpass those of my individual components. I exist in the natural state, which inspires man to shape me in other ways. I'm ancient, but my spirit is always young. As I age, I become stronger, lighter, and more resilient. I resist corrosion, and absorb vibrations. I sail, ride, and glide. I can soar through the sky and even travel into space. I value safety and help to protect people. For example, in car safety systems. Thanks to me, precious energy is saved. I transform into new shapes for beautiful structures, bridges, tall buildings, museums, hotels, and domes. I love sports and creating great experiences. I unleash creativity and promote design. I can be enormous or minute. I adapt to every need, from shaping the wings of Airbus's flagship A380 aircraft to composing a microchip. Innovation is my constant companion. I like to be useful. That's my whole purpose. I want to help advance humanity in building anti-earthquake structures and lighter weight vehicles or pursuing daring projects. I push the limits. Today I'm cleaner and more natural thanks to biosourced materials. I have a lower carbon footprint and can be recycled easily. My life is all about performance. I make people's lives easier, healthier, and more enjoyable. I share your ambitions, contribute to your projects, and help fulfill your dreams. I am a composite material.
So I'm very hopeful this quick video of 2 minutes have give you an idea about importance of composite materials. So now I will be sharing with you people composite materials, how the composite materials are bringing about revolution in aerospace and automotive industry. So today's webinar, I will start with NTU and NCCM's introduction. NCCM means National Center for Composite Materials. Then about composites, their applications, global composite industry and trends, composite industry in Pakistan, and potential opportunities for composite materials in Pakistan. So I will start with National Textile University. I'm sitting in National Textile University. This is a federally chartered public sector university. We are a small university having a student body of 3,000 people with 150 faculty. So we were among the first universities in Pakistan who realized the importance of composite materials, and we started research since 2013 and teaching of composite materials at degree level and later on at MS and PhD level since 2018. We are offering BS Polymer Engineering with specialization in composite materials, MS Advanced Materials Engineering, and PhD Advanced Materials. National Textile University established National Center for Composite Materials in 2018 with very important lab facilities for fabrication, processing, testing, design, and analysis of composites. So we are working to create awareness in the composite industries and to help them in testing, in developments, and for their future projects. So we are a team of about 12 faculty members, and currently we have 6 PhD students and several masters and master students and research associates. So we have created a significant research output in the domain of composites. In the last 6 years, we have completed more than 20 research projects, funded industrial research projects. We have published more than 100 research articles in international journals. About 5 books are published. Some patents have been submitted and awarded. and we have won research grant more than 300 million. This is our latest book, Composite Solutions for Ballistic, which is going to be published with Elsevier very soon. So our main focus is on aerospace, ballistics, sports, and automotive areas. Our research is focused on structure property relation, process property relation for composites, joining of composites with composites and metals, natural fiber reinforced composites, and then functional composites. In fabrication, we have almost complete range of composite fabrication techniques, along with some state-of-the-art machining techniques as well. For testing, we have mechanical testing, complete range of mechanical testing, thermal characterization, polymer synthesis. And then for composite modeling and simulation, we have like COMSOL, Vistex, Abacus, TextGen, all these platforms are available in order to simulate performance of composites. So NTU has developed several success stories with industry in addition to basic research. Some of them are highlighted at my screen. For example, in one of the projects, we have developed smart luggage bags, composite furniture, which is functional furniture, heat resistant, antimicrobial, chemical resistant. We have developed a bulletproof vest, then helmets. We are part of Pakistan's UAV program. Bulletproof border check post, motorcycle helmets, soldier helmets, then nano reinforcement based hockey sticks. So in 2018, which was the last Ideas exhibition in Karachi, we exhibited there with our industrial partners like iTextiles, and some international partners were collaborator in that exhibition. So these are the partners, industries and universities to whom we are working with. You can see most of them are local industries as well as international industries and universities like Turkish, French, Malaysian universities. So composite materials are the newer type of materials. We started with stones. It was Stone Age materials. Then we shifted to copper, bronze, iron, steel, polymers, silicon. And today, the materials that we are using are called designer materials. I mean, the materials that can be tailored, that can be designed with respect to the requirement of end use. So composite materials are one of the designer materials. We have seen their definition in the video. These are the materials which are assembly of matrix and reinforcement with tailorable properties. So reinforcement, it can be in the form of fibers. You can say the long reinforcements or continuous reinforcement. It can be in the form of viscous, or it can be in the form of particulate. So composite materials are not something which are newer. In fact, the human body, it's an example of composite. The bones, they make a reinforcement which is binded with the help of flesh. And none of the individual constituents can make a structure which is more stable than the human body. Similarly, the earth it's an example of composite. So if there is not the reinforcement like trees or the grass, so there will be more erosion, the structure will not be stable. Wood is an example of composites. There are cellulosic fibers which are binded together with the help of lignin matrices. Bones, they are itself example of composites. Collagen fibers, they are binded with the help of mineral matrices. So first man-made composite, first known man-made composite was mud brick, which was developed with the help of mud, reinforced with straws. And the first composite structure, it was in civil application, was made by the Egyptian, almost 4000 BC. So composite materials, they have several advantages. Their strength to weight ratio is very high. Their mechanical properties are superior. Their fatigue resistance is very good. Their resistance to chemical and environmental factors is very good. but they have some disadvantages, like we don't have enough data for safety criteria, and we don't have enough knowledge in order to deal with these materials. So if we compare the utilization of these materials in comparison to other materials. So for example, if composites in the last year were produced 10,000 kiloton, so the market volume of other materials is very high as compared to composites. So let's compare their properties with other materials. If we compare density, they are lighter than concrete, aluminum, titanium, steel. They are little heavier than wood. If we compare their tensile strength, as I have shared earlier with you that these materials have tailorable properties, so we can produce composites whose tensile strength is comparable to alloys like glass composites, and we can make the composites whose strength is comparable with the steel like carbon composites, and even we can go beyond like using boron composites. Their tensile modulus is also tailorable. You can have composites having a range comparable to wood, to a modulus which is comparable to steel. So then why, if their properties are very good, so there is question that why composites are used in like a smaller quantity as compared to other materials. The first answer that we listen oftenly is cost consideration. Composites are higher in cost. In fact, this is not the right response. Composites, if you compare having the same kgs of both materials, then composites may be costly. But in general, when we use composites, we use less weight of composites. So it means at the level of part, composites will not be costly. So for composite materials, we use fewer kgs. The fabrication cost, it may be lower. As their weight is lesser, so transportation cost, these are generally lower. And one very important thing for composites is that they need less maintenance as compared to conventional materials. So then what is the limiting factor? The limiting factor, in fact, is not the cost. In fact, it's lack of knowledge, lack of engineers, or lack of the human resource with the knowledge and experience to design and to deal with these materials. So applications, we have seen many in the video. There are some more in sports application. We are producing composites in hockey sticks, bats, rackets, helmets. In medical applications, many prosthetic and other medical equipment are made using composites. Industrial application, tanks, pipes, fans, cooling tanks. In defense application, bulletproof vehicles, helmets, jackets. In marine applications, the boats. Structural applications, housing. In defense application, there are a lot of applications of composite materials in weapon systems, in tanks. In aerospace, in fact, it's the most important application of composites in passenger planes as well as in the fighter plane. So you can see two examples, B-2 Spirit and 787 on your screen. UAVs is one of the emerging application of composite materials. The growth rate of UAV is among the highest in aerospace applications. Satellites, in housing, furniture, doors, infrastructure, energy sector, wind turbine blades and towers, trains, buses, cars in automotive, motorcycles, bicycles, helmets. So there are many applications of composites. We have gone through the video as well as I have shared with you some examples. So whenever we classify composites, there are three major classes with respect to matrices that we use: polymer matrix composites, ceramic matrix composite, and metal matrix composites. So polymer matrix composites are the mostly used composites. We made them by combining a reinforcement, which may be in the form of fiber, which may be in the form of thread, or maybe in the form of fabric, with the polymer matrix in order to bind it, and then we make composites. You can say roughly 85% of the composites that are existed today, they are made using polymer and the reinforcement. In general, polymer, they cannot withstand at higher temperatures. You can say higher than 400 degrees centigrade, they cannot withstand. So for high temperature applications, composites like ceramic matrix composites. There is some, we have some
Please
question.
continue, sir. Please continue, sir.
So for high temperature applications, we cannot use polymer matrix composites. So there we use ceramic matrix composites. You can see some applications like in the jet engines, the brake discs, and other things like this, carbon, silicon, carbon, and other applications. Similarly, in general, the ceramic matrix composites, they are brittle. So the new emerging type of composites is metal matrix composites. So they are little less brittle as compared to ceramic matrix composites, and they can withstand at high temperature as well. So for manufacturing, mainly now I will be talking about polymer composites, as they are about 85% of the composites. So for manufacturing, there are two types: direct manufacturing, indirect manufacturing. Indirect manufacturing, we mix the fibers and polymers directly. So there are further, they can be classified in open mold, closed mold, pultrusion, and filament binding. I will be sharing with you some snaps in order to give you an idea about these techniques. So indirect manufacturing, in that we purchase a pre-preg, in fact, an intermediate form. We can purchase it from somewhere else where they mix the fibers and polymers. We take it, we give it a specific shape using autoclave, using some pressure molds. We give them a specific shape, and then we cure it. So here the fibers and polymer, they are being sprayed on a mold. This is open mold technique. Here they are placed using hand layup. So hand layup, it was the mostly used techniques 10 years ago. Today, its percentage is about 30%. Then vacuum infusion, we use vacuum in order to infuse the resin into the reinforcement. We have autoclave, we have resin transfer molding, two-sided mold or closed mold. And then we have filament winding, which is generally used in order to make axisymmetric parts. So if we compare performance and production volume, pre-pregs are mostly used for high performance composites. For example, in aerospace, in automotive, so they are being preferred, but their production volume is lesser. And short fibers, as we see shades or other low-tech applications around us. So these are the short fibers with low performance and high production volume. So if we look at the global market, it's about, in 2019, it was about 91 billion US dollar with a growth rate of 7.7%. The share of the sectors like wind turbine is about 14%, construction 16%, electronics and electrical equipment 16%, aerospace 15%, and pipes and tanks about 20%. We look at growth rate in all these sectors. So aerospace is at number 1 with 10%. Wind turbine, wind energy, especially wind turbines, 8%. Transportation or automotive applications, 7%. Then marine, 6%, and then construction. If we look at region-wise market and region-wise growth rate, So with respect to market, USA is at number 1, followed by European Union, China, and then India. And if we look at the growth rate, India is leading, followed by China, Europe, and USA. So where Pakistan is standing? Nowhere, unfortunately. So major market drivers are development of megacities, urbanization, health. For example, there is demand for infrastructure, safe, eco-friendly transportation, and clean, renewable energy, which is driving the application of composite materials. If we take into account full life cycle, composites are again a priority, again a choice, because they are durable, maintenance is requirement of maintenance is lesser. And of course, if the weight is lesser, there is energy saving as well. And access to composite is increasing. So we are producing them at mass scale. There are new entrants in the market. And with the passage of time, there are new applications of composites as well. So let's go to Pakistan, what we are doing in composites and what are the relevant sectors. So in Pakistan today, 120 से 150 के करीब small or medium sized organizations हैं which are working in different regions. The main region is Sialkot, which is dealing with sports equipment. Lahore, Faisalabad, Karachi, mainly they are working with daily life glass fiber reinforced plastics. We have a small cluster of aerospace industry as well, with main center at Canberra, and then there are some small companies who are making parts and some small UAVs using carbon fiber composites. Automotive is there, but they are not mainly using composites, only in some parts. So today, the market value of Pakistani composite industry is about 50 million US dollar, which must be much more than this. So the first sector where the composites can be employed, where is a great potential of composite materials, is construction sector. So in construction sector is the fastly growing sector in Pakistan, with a growth rate of 9.1%, which is expected to rise up to 12% in 2020 and 2021. And there are global trends in this sector for employment of composites. Use of prefabricated composite panels, it's increasing. ये बने हुए इस तरह के panels होते हैं जिसको आप quickly join कर सकते हैं in order to make the structures. The hospital in China that was built in 7 days, it was example of manufacturing of quick structure using composites. Building facades, they are lightweight, they serve the purpose, they are durable, and can be made very quickly. Then steel rods, they are being replaced with carbon fiber and fiber reinforced concretes. Rods are being replaced with composites, and structure or concrete, it's becoming fiber reinforced concrete. Low cost housing is an example of composite. You can make quick houses very quickly over a period of like a 2-bedroom apartment over a period of 2 to 3 days. And it's a low cost as well. And then there is 3D printed houses. They are also there in application. Composites in automotive industry. I will start with global market, then I will come to Pakistani market. So composites, they are, when we talk about composites in automotive industry, 40% of them are thermoplastic composites, carbon fiber composites 10%, exterior segment about 7%, and natural fiber, which are like increasing with the passage of time. There is a great opportunity for Pakistan, क्योंकि हम agriculture country हैं, तो हमारे पास ये बाकी carbon fiber और दूसरे तो नहीं है, but still natural fibers are there, so we can get our share very quickly in this segment. So in automotive composites, We use fibers, glass, carbon, and natural fibers. This is with the order of decreasing volume: glass maximum, carbon natural. Resins, we have thermoplastic, thermosets. Manufacturing process that we use is compression, injection molding, resin transfer molding, etc. And the main applications are interior, exterior, a little bit structural parts, and some other small portions as well. So here is an example of composites being used in automotives: car seats, bumpers, back seat cover, front seats, door panels. Again, some examples: battery tray, heat shield, trims, roof skin, engine cover, etc. So today they are used in some expensive as well as medium range cars. Here are the models of Audi, BMW, Mercedes-Benz, Rover, Ford, and Toyota. So I have mentioned the parts as well. I will be sharing with you people the slides so you can have an idea in detail. So this is the new trend: natural fiber composites in automotive. Panels. This panel is made from hemp and PLA, flax and PLA. So we have hemp, we have flax in Pakistan. So in C-class Mercedes, there are more than 30 parts which are made using natural fiber composites. These are some other application: carbon fiber wheel, metal composite hybrid structures, torque tube tunnel, battery case. In Lamborghini's Sesto Elemento, I'm sorry if I'm not pronouncing it correctly, 80% of the car is made using carbon fiber reinforced plastics. Toyota Lexus LFA has 65% of carbon fiber composites. So if we come to automotive sector in Pakistan, it contributes about 3% to GDP. When I say automotive, so I'm including the bikes in that as well. About 3,200 units. About 3.5 million people are employed in this sector. And we are producing 0.2 million vehicles per year. Today, there is no major contribution of composites in our automotive sector. सिर्फ एक या दो covers हैं, एक उसके अंदर engine cover है और एक और छोटा सा है जिसको हम composites का use कर रहे हैं. Because there is limitation of design, हम सिर्फ assembler हैं, इस वजह से we are not allowed कि हम उसके अंदर अपनी मर्जी से जो है वो changes कर सकें. But there is lot of space in buses and trucks जिनकी जो body है वो पाकिस्तान के अंदर बन रही. Composites in aerospace, it was started with aluminium in early 90s. Then we shifted to steel, titanium, metal matrix composites, reinforced carbon composites, polymer matrix composites. And today, since 2000, the main application is fiber metal laminates. So in composite materials in aerospace, we are using metal matrix composite, polymer matrix composites, fiber metal laminates. Here I have listed some parts and the models in which aircraft models in which composites are used. So again, the main techniques which are being used are resin transfer molding, autoclave processing, and filament binding. So resin transfer molding is used in order to make spars, ribs, etc. for the fuselage. Autoclave is mostly used for nose cone, wings, fuselage, etc. And for the barrels, we use filament binding. So here are the examples of two you can say the airplanes having a maximum percentage of composites. The first one is Boeing 787 Dreamliner. It has about 50% of composite, and same was with A380. So skin is made from composites. It's a general rule. Whenever we talk about aerospace applications, the first application of carbon fiber composites is skin. So it's made from composites. Then we have fiberglass. So parts where there is more abrasion, so we use fiberglass or Kevlar composites. So almost same is for A380. Here we have listed fighter aircrafts, most of the fighter aircrafts around the globe, with percentage of composites which is used in these aircrafts. F-22, the mighty F-22, it has about 24% of composites. F-35, 35% of composites. B-2, 34. F-18, 90%. F-16, 5%. AV-18, 22%. Eurofighter, 40%. Rafale, 26%. Mirage, 7%. Saab, Gripen, 25%, MiG-29, 15%, and Tejas, 40%. So whenever we talk about composite, it means they will be making aircraft lighter, having long life, or agar lighter hai, to with same fuel, it will increase your range. ये इसकी maneuverability जो है वो उसको increase कर देगा. So it's very important कि हम composites जो है वो उसको use करें in aerospace application in order to improve its performance. UAVs. In the last years, per annum consumption of composite materials for UAV industry, it was about 738 metric ton per annum. So there is a lot of demand of composites in order to make them maneuverable, payload effective. So इस वजह से जो reliance है composites के ऊपर UAV का वो increase होता जा रहा है. It is expected कि जो drone market है वो it will be increasing up to $64 billion by 2025. और जो annual इसके अंदर ये growth rate है it's about 34%. और UAVs वो जहाज हैं जिनके अंदर composites का maximum utilization है, except some you can say load-bearing parts. Most of the UAV is made from composites. These are the applications. They are UAVs. They are used almost today in all the applications: product delivery, search and rescue, agriculture, internet carriers, for military applications, space research. They are everywhere. And now we have 3D printed UAVs as well. So अभी हम composites की बात कर रहे थे. So जो research है, जो development है, it's one step ahead. Composites के अंदर one of the new trend is 3D filament reinforced 3D printing. So we have started making composites using 3D printing. So aerospace sector in Pakistan, we have a big complex, Pakistan Aeronautical Complex. If we talk about private industry, in fact, it develops with the development of aerospace sector. Pakistan के अंदर aerospace sector, in fact, it's not very big. So इस वजह से जो vendor industry है वो भी इतनी ज़्यादा नहीं हुई. But we are a big country. और जो market, global market है, it's very big. So we should start looking for global market. The opportunities are very large, very big, especially in the domain of UVs. So what we are producing at Pakistan Aeronautical Complex is GS-17 Thunder. There'll be small application of composites as well. Then trainer aircrafts, UAV, and projectors. The last sector is sports sector in Pakistan. We are exporting about 400 million of composites. Why I'm telling you about sports sector, because in fact, ये webinar जो था वो it was about automotive and aerospace sector. लेकिन हमारा जो sports sector है, they are already dealing with composites. So they have the potential to shift to aerospace and automotive sector very quickly. So that's why I have included a small introduction about the sector as well, and share with you the opportunities. So exports of the sports sectors are about 400 million US dollar. There are more than 2,000 units in Pakistan, giving an employment to 0.2 million people. And they are producing a lot of applications, but mainly related to composites are rackets, bats, hockey sticks, etc. So in the sports sector as well, there are some global trends like introduction of 3D printing. You can see many applications, rackets, boats, etc. Bicycle, helmets. So we need a shift in sports sector as well as shift of sports sector. So I will be sharing with you quickly SWOT analysis of Pakistan's industry, Pakistan's composite industry. If we talk about our strengths, we are not a country who doesn't know, where industry doesn't know about composites. There is also already existing composite industries in sport as well as aerospace sector. There is an existing automotive sector, though they are not using composites significantly. लेकिन है, it's a big sector. 2 lakh जो गाड़ियां हैं, it's a big sector. If we compare with the developed world, our manufacturing cost is lesser, is lower. And there is availability of specialized engineers. दो के इसमें बहुत ज़्यादा नहीं है, लेकिन still we have specialized engineer. There is testing and research and development facilities. Our center is one of them. And there is platform of like Pakistan Aerospace Council, जो कि already मौजूद है. ये आज का जो हमारा webinar है, ये एक awareness campaign है about composites. So it means कि we know people are working there. People are we know the people who have the capabilities, who are doing testing, who are doing research and development. So we are not new entrants into the composite. What are our weaknesses? The first thing is small local market. Second thing is incomplete value chain. हम fibers नहीं बनाते, glass fiber, carbon fiber, they are mostly used in composites. हम नहीं बनाते. लेकिन जो natural fiber है, उसमें हमारे पास local जो resource है, वो it's available. हमारी जो existing industry है, composites में, it's a low tech industry. Low tech products जो है वो बना रही हैं, this lack of innovation, or ultimately they are not very cost efficient. जो tariffs हैं इस पे raw materials पे, इस पे glass पे, carbon पे, they are high, so government needs to intervene in this. जो trained technicians हैं, we have some engineers, लेकिन जो trained technicians हैं वो they are not available. और जो education in composites है, though we are offering mechanical engineering, polymer engineering, chemical engineering, लेकिन जो composites के अंदर education है वो specialized is not available. Opportunities क्या हैं? सबसे पहले तो जो industry के लिए there is a big global market. There is a potential local market as well. We need to work on it in automotive sector, especially buses and trucks. There is a fast growing local construction sector. अब जब ये grow कर रहा है तो there will be need कि ये quick करे, और ये इसको you cannot make it quick, low cost and energy efficient without composites. कुछ चीजें ऐसी हैं which are new for everyone. Evolution of new technologies such as fiber reinforced 3D printing. It's quite new. So if we start it today, we will be like going side by side with the world. इसमें जितनी भी new products हैं, we can get our share easily. And natural fiber composites, these are also a big opportunity due to local availability of fibers. So हमारी किसी के ऊपर dependency जो है वो नहीं रही. इसके अलावा जो universities और जो हमारे technical education के institutes हैं, they have an opportunity, they should start education. the sector of composite materials. We have some threats as well. Composites you have, they are replacing very quickly the conventional materials. So regional countries like Bangladesh and India, they are investing in this domain very quickly. There is a time to act. अगर हम नहीं करेंगे तो जैसे टेक्सटाइल में इंडिया और बांग्लादेश आईटी के अंदर जो इंडिया तो they have grabbed the opportunities. I fear that we will lose this opportunity as well. So composite materials, if you want to enter into a futures manufacturing economy, it's not possible without composites. We cannot imagine it. So this was a first effort to sit together, to discuss together, to disseminate awareness and information about composites. Think about it. What we can offer from National Textile University, trained human resource, product development services, testing, trainings, and feasibilities, business feasibilities, if you wish. Thank you very much. Over to you, Dr. Shisa.
Bismillahirrahmanirrahim. Asif, video sharing allow कर दीजिएगा. Bismillahirrahmanirrahim. Thank you very much, Dr. Yasir and all the participants. I think it was very, very valuable and informative session. Participants must have benefited quite a lot. Question पूछेंगे. We also had a participant from Turkey. So, if permitted, can we request Mr. Member to have any question, please? Mr. Member, do you have any question? So if not, then we have one of the renowned businessmen and technologists with us, Mr. Mahmood Sharani. Mahmood Sharani sir, do you have any question, please?
जी अस्सलाम वालेकुम. आवाज आ रही है?
जी बिल्कुल आ रही है.
असल में ये बड़ा मैंने अभी देखा बड़ा इम्प्रेसिव है और बड़ा डिटेल्स था और इत्तेफाक से मैं इनके पास फैसलाबाद यूनिवर्सिटी भी गया हूँ. वहाँ भी ये इस सारे बारे में काफ़ी सारी नॉलेज मिली है. इस पे काम करने की ज़रूरत है और मैं इस पे काम कर रहा हूँ. अभी के कुछ चीज़ों में मेरी शायद रिक्वायरमेंट आएगी. तो इन फ्यूचर जैसे हम बड़ी जिके बनाते हैं, बहुत बड़ी हैं, उनके स्ट्रक्चर्स में जैसे इन्होंने अभी मुझे बताया कि स्ट्रक्चर्स बन सकते हैं. ये एक मेरे लिए बड़ा पॉजिटिव इसके अंदर चीज़ है कि ये इतना बड़ा स्ट्रक्चर जो हम स्टील में बना रहे हैं, इतनी मेहनत कर रहे हैं, एक्यूरेसी में वो अगर यहाँ बनेगा तो उसका क्या रिजल्ट होगा. तो मेरा ख्याल है कि इन फ्यूचर मुझे अगेन इनके पास विजिट करना पड़ेगा और इनके साथ फिर मैं लाइन अप रहूँगा इंशाल्लाह. तो
Thank you very much, sir. We have Mr. Mohammed Shafiq. Shafiq sir, yes please, do you have any question? आपका माइक ऑफ है. माइक ऑन कर लीजिए प्लीज. जी शफीक साहब, आपकी आवाज नहीं आ रही, आपका माइक अभी तक ऑफ है. मुझे माइक आपका नजर आ रहा है, ये ऑफ है अभी. नहीं, आपका माइक ऑफ है इसलिए आपकी आवाज नहीं आ रही. आसिफ, काइंडली आप माइक इनका ऑन कर देंगे.
राइट सर.
शफीक साहब अभी तक आपका माइक ऑफ है. आसिफ, can you please turn on the mic?
Now I have done this. It was unmuted from you. This was muted from your end. Assalamu alaikum. It was very informative. I was struggling to be connected on the internet. Then I have to call you from Dubai to let me have the correct ID because it was not accepting on my computer. I'm a mechanical engineer, 71 class of UET. I've been in Dubai for a long time. Since this was very informative, I missed part of it, but I will request Professor Saab to send me the proceedings. And if we can do something from here, if you need my expertise on this one, I will be very happy to contribute. Yes, it is very right that Pakistan has been way behind in the composite materials. Itself is a very advanced material science, which probably is well versed in USA and China and other countries. Unfortunately, India has already gained some superiority as far as the industry is concerned, but we are not far behind, and we can contribute something. Please be in touch with us, and if we can be of any help to Pakistan, definitely we can do that. The composite materials I've seen in construction materials, they are also utilizing, apart from composite material, they are using plastic refuse. Recently I've seen they make blocks of all plastic by compressing all the plastic materials, and those blocks are really, really strong. They are much stronger than our bricks, and they can be assembled as Dr. Saab has already told us with the composite bars in a few hours time. So the composite materials that are lightweight, they are high in strength, used in aeronautical industry and other. But I will say that it is very informative, and I'm thankful to Dr. Saab. But I will need some more information because I missed about 50% of your seminar. So I'm really thankful to you that somebody somewhere in Pakistan is working on this one.
Thank you very much, sir. The recording of this webinar will be available on Aerospace Council website. In addition to that, whenever you are visiting Pakistan, we look forward to seeing you over there and having more interaction.
Thank you very much, sir. And it's very kind of you. Thank you very much.
Thank you, sir. Can we have some comments or question from Mr. Saqib, who has already sent chat in the chat window? Saqib sir, over to you.
Hello.
Yeah.
Hi. I was just asking about, because of the complexity of composite materials, I was just thinking about in terms of repair and maintenance. It seems to be more problematic than metals. So how do you kind of address that? I put the question in the chat, by the way, if you want to look at the whole thing.
So, yes, sir.
Yes, in fact, we are comparing composite materials with metals. So in fact, these are the different materials. They have different techniques for machining. They have different techniques for joining. So we do it normally. There is nothing which is difficult. There's only the knowledge gap.
Thank you. Can we have some comments from Dr. Aslan Sheikh, please? Please introduce yourself also. Mr. Asad Jabbar has a question. Asad Jabbar, can you please share your comments?
Yeah, hello, can you hear me?
Yes, we can hear you very well.
Yeah, so I'm Asad Jabbar. being a CTO at Grid 3D in Karachi, Pakistan, being working as an additive manufacturing consultant and providing product development services for the last 5 years. We have been working with 3D printing and additive manufacturing and developing prostheses, especially for the disabled people in Pakistan, and working with some of the automotive sector. Um, what I see is the composite material is being very highly used in the medical devices, especially when you develop when you do non-invasive surgery, like developing titanium materials to support the biomechanics of the body and to assist the exomechanical devices, for example, wheelchairs and assistive devices. So I see a great opportunity in there and developing medical devices and exporting it to European countries. But my question is, how can we develop these materials within Pakistan, or how can we get great access to these materials so we can utilize and make product out of it?
Dr. Yasser.
जी. So if I understood rightly, your question is कि जी हम ये जो medical devices हैं, how can we produce them in Pakistan?
And how we can get the raw material for it also, like titanium.
Raw material, as I have shared with you earlier, that most of them, they are not available in Pakistan. We are a small market and there's no production facility for raw materials. But they are available in the global market. You can import from Japan, Korea, China. These are available. So for production, if you need to develop a feasibility or like to develop a concept paper, we can help you. You can drop a message to Dr. Saab, and we can develop very quickly a feasibility with you.
All right, thank
you. Can I just share one thing? In UAE, there is a company which is called Strata. They are manufacturing different parts for all the aircrafts, mostly for Boeing, tail and other stabilizer and all this. They are not manufacturing it here. They are getting it rolls of composite material from outside. So the possibility is, as Dr. Saab said, you can export it from outside and you can manufacture your stuff, your components accordingly.
Just to share, I came to know that there is an Institute of Additive Manufacturing which is being established in Islamabad. As we get more information, we will share with the industry. So I'm very happy to see that 3D printing and additive manufacturing is being pursued by Mr. Asad Jabbar, and I'm sure his expertise and knowledge will be very useful.
अगर इसमें डॉक्टर साहब, if Asad, if you want to don't enter into conventional composites, so you start doing 3D printing or additive manufacturing with filament inside, with carbon fiber filament inside. So it will be composite, 3D printed composite with a very superior material.
Yeah, so basically we work with PLA, ABS, PETG, carbon fiber, nylon. So we have worked with many different materials, and recently one of the colleague who was working in European market came to visit us and showed us the titanium material made out for the titanium material being used in the body to support the hip joint. So I see a very global disruptive market of developing these kind of devices within Pakistan, because the technology we can get in here, but unfortunately, as we seek, there's an issue of NOC from the Ministry of Interior for getting 3D printers. So that's one of the reasons, that is one of the blockages that I see. So it's fortunate to know that there is an Institute of Additive Manufacturing Development in Islamabad, and I would like to be a part of that and see how can we get the technology here and develop materials here so that we can export all the products across the world and develop more market of Pakistani products with for the other world and develop more jobs here.
Thank you, sir. Can we have question or comments from Madam Halima Sadia, who is part of our participants? Can we have comments? Somebody mic is on.
Dr. Sab, actually you are connected from two devices, so voice echo starts when you start speaking from two devices. So you have to use only one device.
Yeah. So can we have comments from Madam Halima Sadia, who is part of our participants? Halima Sadia, please. If there are no comments from Halima, then can we have comments from Ambreen Shafkat? Any question or comments? Can we have Mr. Shafin Chaudhary? Do you have any question or comments? Okay, I think. जी शफीन
जी अस्सलाम वालेकुम मेरा नाम बिलाल रखी है ये मेरा आईडी पे नाम कुछ गलत आ रहा है शायद तो मेरा क्वेश्चन बेसिकली रिपेयर टेक्निक्स के हवाले से था कि रिपेयर टेक्निक्स जो है हम किसी भी चीज़ को यूज़ करते हैं उसके मोल्ड्स जो है एस्टेब्लिश कर लेते हैं इन केस ऑफ एनी रप्चर एनी एक्सीडेंट वो अगर उसमें कोई डैमेज आ रहा है तो उसकी रिपेयर टेक्निक्स जो हैं उनका भी अवेयरनेस जो है वो ज़रूरी है क्योंकि उस कॉन्फिडेंस के बगैर कोई चीज़ डेवलप नहीं हो सकती एक चीज़ दूसरी चीज़ ये है कि हमें रेडिली अवेलेबल मटेरियल्स के ऊपर जो है वो थोड़ा सा कंस्ट्रक्शन मटेरियल में काम करना पड़ेगा जो कि रिप्लेसमेंट बन सकें जैसे इन दी प्रेजेंट मार्केट जो है हम इंटीरियर डेकोरेशन के लिए यूज़ कर रहे हैं अपने कोई लेबल्स भी और उसके बाद हमारे पास वॉलपेपर्स भी आते हैं इस तरह की चीज़ें यूज़ करते हैं उससे पहले हमारे पास पीछे उसको सीमेंट की एक लेयर्स जो है वो भी एस्टेब्लिश करना पड़ती है तो क्यों ना हम ऐसा ही कोई चीज़ एस्टेब्लिश करें जिससे हमें सीमेंट की रिप्लेसमेंट मिले जो कि एक थर्मल स्टेबिलिटी भी दे और हमारा एक हीटिंग और कूलिंग एक्सपेंडिचर जो है उसको हम एक कंट्रोल में लेके आ सकें उसके ऊपर एक रेडिली अवेलेबल हमें एक कंपोजिट मटेरियल जो भी प्रोवाइड कर रहा हो और वो कंक्रीट के साथ या हमारी जो आम जो स्टोन वॉल्स हैं उनके साथ जो है उसकी एडहेसिवनेस भी हो
Thank you very much. We have noted your suggestion, or inshallah we will try to see how can we adjust as far as your comments are concerned. Can we have some comments from Tahir Shah? Tahir Shah.
अस्सलाम डॉक्टर साहब कैसे हैं आप ठीक हैं It's been a long time. I actually had to walk out of the lecture because I was a urgent matter, but I'm back now. I think lecture जो मैंने सुना जहाँ तक was excellent. I think it was a very good summary of the situation of composites worldwide, and also the lecture talks about what should be doing in Pakistan. I think that was more important than anything else, to be honest. And I think it's Dr. Yasser has highlighted the important areas in Pakistan. My just one thing question is actually, are we looking at self repairing composites? Is there any work going on in Camera or in important strategic organizations? Because there was another area of importance where we have self-repairing composites. I think that is, and also I think Dr. Yasser has not mentioned, I think while I was listening, about his executive composite work, because that is again an important area for a future area for the composite development. On the whole, I think again, the focus which Dr. Yas is driving towards the natural composites. I think we should be looking at fully natural composite. I think he mentioned one, which was based on PLA and natural fibers. And that is one area, but there are other areas for more common applications, I think, which we can actually look at these composites, especially where some level of degradation is, biodegradation is required, where materials need to be disposed of. I think that area we should be also looking at recycling of composites. I think, again, right from the beginning, where we're moving into this area, we should be focusing also on recycling of composites. So I think on the whole, I really enjoyed whatever lecture I attended, part of it. I think I attended most of it. And I think it's a huge field for Pakistan to develop. And I think together with industry, and you can play a very leading role in this area. And I think we look forward to really developing. I think the thing to do is we start developing sort of model projects. For example, let's do a project for some model project for, say, a small housing state. Yeah. Or even start with a house. Start totally, wouldn't say 100%, but mainly composite-based house. I think, can we develop a model and look at the material which we can get it locally, and also what we can actually easily obtain from abroad. So I think we should be looking at practical things. I think working in the high-tech area like aerospace, even the modern automotives, that will come definitely to Pakistan. But I think our initial needs are, we need to identify what are our major needs, apart from our strategic needs. I think we should be looking at those. So I think these are just basic. There are a lot of comments, but I think if we start talking about these things, I think we can sort of have actually meetings, regular meetings on these things. We should have regular meetings on these things, and we should set up a strong network of composite people who are working in composite industry, academia, and even strategic organizations. So I think we should have a regular discussions, pick up a particular topic in composites. For example, let's talk about next time just one area of composite, which is construction industry. I think that is because that is the key word which is being used these days by the government as well, construction sector. So can we do some work in that area and develop some model, even parts of the houses? Yeah, like somebody mentioned insulation. Yeah, insulation of houses using concrete alternatives. So I think we could start working on some specific areas, which I think will deliver more than I think with just working generally and everything. So let's start focusing on certain areas and start working on those as teams. Well, Dr. Saab, lovely to see you. Yeah, and hopefully we'll get together soon when Corona allows us. So I think we will get together. And thank you very much, Yasser, for a lovely lecture. Very good lecture. Thank you.
Thank you. Dr. Tahir, we would also like to benefit from your knowledge and experience. MashaAllah, you have worked in so many cutting-edge technologies. So we will definitely look forward the opportunity to benefit from you. And
I'm always with you. Always with you.
Yeah. In addition to that, if any other participants want to contribute through a webinar, you are always welcome. Let's hope for the best. And thank you very much for all the participants. Over to Asif for the closing remarks.
Thank you, Dr. Yasir Nawab Saab, and thank you, Dr. Arshad Ali, for your valuable time and sharing the thought-provoking knowledge about the composites and their opportunities in Pakistan. The recording of this webinar will be available on Pakistan Aerospace Council website, as well as YouTube channel of Asian Institute of Industrial Air. Pakistan Aerospace Council will continue to arrange such webinars for knowledge sharing related to latest technologies. Apart from this, if any one of you want to contribute for knowledge, for sharing their knowledge, they can contact the focal person of Pakistan Aerospace Council. So thank you so much, everyone, once again, and stay safe. Have a nice day. Allah Hafiz.